We went to the International Space Station to help build it. So we took up a piece of the truss, which is right here. The truss is like a big beam that goes across the top of the space station and holds the solar panels and also holds computers and radiators and other external equipment. In addition to this truss piece that we added on to the end, which I'll show you in a minute, the end of the existing truss, we also took up this stowage platform. This is about a 7,000-foot platform. I had the great pleasure of using this robotic arm from up here in the flight deck and grabbing onto the stowage platform, pulling it out of the payload bay and transferring it to the space station arm, where we then took the space station arm up to the top of the space station where this stowage platform now sits. And using a small laptop computer, National Space Station. And I think this is pretty interesting. You would think that we would fly up to it, but what we actually do is, in the video, did you see the orbiter doing a backflip? Okay, so what happens with that, and this was after the problems we had with Columbia and the foam striking the bottom of the orbiter, striking the front wing of the orbiter, and unfortunately it was very, very sad. We lost our crew and the orbiter. This is what the space station looked like when we arrived, and we added on, see this piece right here? That piece of the truss? That's what you saw in the back of our payload bay. And we added that piece to this end here. And it was a spacer for the extra set of solar panels that go here, and the other one set of solar panels goes here. That stowage platform that I showed you, we put up here. And on that stowage platform, one of the pieces that we took up was a very large gyroscope. And we changed out one of the 4 gyroscopes that's up here on the space station. And happened to break about a couple months before we launched, so we took up the new gyroscope. Here's what the space station looks like now, and I would love to go back. It's a marvelous, marvelous place. And the pieces that were not on there when my crewmates and I were up there were the European laboratory and the Japanese laboratory. This is the United States laboratory, and the back half of the International Space Station is the Russian laboratory. The entire space station, when we dock, by the way, we dock right here, and the space shuttle would be hanging down like this. So you can kind of imagine how large the station is. It is slightly larger than an American football field. It's a fantastic laboratory. There is no up or down in space, so I did not put in this picture upside down. This is one of my crewmates, Clay Anderson, working on the Melfi, which is a minus 80 degrees centigrade freezer where we keep biological specimens and some of the science that we're doing. This is a perfectly natural position to be in when you're in space. It is also a wonderful, wonderful home. And these are my crewmates and I at a dinner we had one night on the Russian side of the space station. My crewmates on my mission, we had all Americans and 1 Canadian and 2 Russians. It changes depending on the mission. But our Russian crewmates were Fyodor, who was the commander of this International Space Station, and Oleg Kotov, who was one of the Russian cosmonauts, and Clay Anderson, American astronauts. Dave Williams was our Canadian crew member, and the rest of my crewmates up here are all American. On this particular meal, this was just before we... Can you tell what this is? Yeah, scrambled eggs. What else? Hot sauce. Okay. And a tortilla. So one of our favorite meals was breakfast burritos. Some of the work we did, that truss piece is out here at the end, and this was just after we had added it, and Rick and Dave, our 2 crew members who were outside, are making their way back into the space station. So what we had done was used our robot arm on the space shuttle and our robot arm on the International Space Station. We hauled the truss out to the end where Dave and Rick hung out at the end with their bolt drivers, and basically we were using the arm to take that piece in and being very, very careful because we had about 2 inches of clearance there's a battery box out there that we did not want to hit. Not a good idea. And so Dave and Rick basically guided us in, saying a little bit left or a little bit right, or they'd say pitch it up a centimeter or roll it to the right a centimeter, things like that. And then we brought the truss piece in as soon as we made what we call a soft dock. Then they took out their bolt drivers and bolted that piece into place. Pretty interesting. Rick Mastracchio, this was his second space flight, but his first spacewalk. He's a typical engineer, very capable, very competent, very confident, and through all of our training, we trained for about a year, he always was very even-keeled in everything that he did. You never heard his voice go up, you never hear his voice go down or drop low. After we brought both guys in and we were unsuiting them, in this case, my crewmate Tracy and I are getting ready to fly the robotic arm, and we're reviewing our procedures before we do the flying. You fly it with the hand, here's one of the hand controllers. There's another hand controller that looks similar to this that's behind Tracy's back. You can't see it there. I think you can see by looking out the windows, you're basically looking at structure, big pieces of the space station. So, International Space Station. And this is just an example. Here's that stowage platform that we had transferred from the space shuttle arm to the space station arm. Remember that gyroscope I told you about? Well, this is that gyroscope. You can see it's quite large. It's about 850 pounds, but it does not weigh anything in space. But it does have more mass than Dave has. So Dave is going to take the gyroscope up to the top of the space station. You can see it'd be pretty hard to move yourself along the space station and hold onto that gyroscope. So what we've done is attached his feet to the end of one of our robot arms, and then we'll actually carry him up to the station. Duct tape. Not quite duct tape, but actually duct tape, we do use a lot of duct tape. What you've got here, it's almost like getting into a ski binding. On a ski. And then you can't see it, but we do have tethers. There are wires that we actually use to also wire onto make a connection onto the foot restraint here. Dave's holding onto this big gyroscope. He also has a tether attached as well. This was a fun story. What you're looking at here, this is a picture, this was one of my very favorite views from our space station. And this was the first view I saw when we attached to the station and I went into the Russian side of the International Space Station. You're looking out one of the Russian windows and you're looking towards the front of the station. It looks like it's really close, but actually there's great distance here. And here's the Soyuz, and then way in front of the Soyuz is our space shuttle. Of course, our space shuttles do not go up to the space station anymore, and we are relying totally to take our astronauts along with our international astronauts and the Russian National Space Station. So we are still flying in space. The difference is right now for the next few years, we have no way of getting our own astronauts up to the International Space Station. We just don't have a way of launching. We're relying on our Russian friends to do that for us. But we have a lot, and it's very interesting, and I'm very excited to see what's going to happen over the next several years. We have a lot of private industry now working on developing that next space launch vehicle. This upcoming February, so next month, the company called SpaceX will be launching a capsule that goes up to the International Space Station. Will dock for the very first time. So it will be the first time we have a United States commercial company doing this, taking supplies on the Dragon spacecraft to the International Space Station. But that is all in preparation for eventually being able to do the same for people. Okay, remember that closet that I showed you that I said we carried about 5,000 pounds worth of science equipment? All of that we had bagged in these soft bags like you can see in my crewmate Al Drew's hand here. This particular bag, I'd say is about the size of half of this podium. And squeezed between his legs, he's got a double size of those bags, so it's a little bit larger than this podium. And it's very easy to move a lot of equipment around in space when you don't have to fight with gravity. So you just squeeze the big bag between your legs, hand one bag in your arm, and then take your hand and very gently shoot yourself through the length of the space station. Like, so weightless is also very fun to do science, and astronauts actually like to play with their food and do a lot of science with the food. Can you tell what this is? Okay, I'm hearing several things. I did hear a drop of water. Yes, that's what happens to liquid when you break the ball into a billion little balls of water. You want to make sure you have towels there ready to mop everything up. Other times, if you throw them a little gently, it's very interesting to just kind of stick with surface tension to the outside of that ball of water and kind of just make their way around the outside. You can see, oh, let me back up for a minute. Sorry. Can you tell what this is? Yeah, a piece of dental floss. So, Scorch here is taking that piece of dental floss and very carefully, I'm sorry there's no motion on this, but he took it and just kind of got a nice little spin going on that glob of water to see what would happen to the M&Ms inside. You can also try cutting it. There's all kinds of things you can do. And then when you're done playing, you can just take your straw, stick it in, suck out all the water, and then you've got some floating M&Ms, so like a fish, you can go after them. Like I said, we like to play with our food. How about that picture? Can you see Leland in the background? All right, and for you youngsters in the audience, I want you to think about the science behind this. Okay, here's a glob of water that Leland has. Here's his straw. Here's the real Leland. Why is he upside down? Okay, another very favorite thing to do. The work is great, the floating is great, the camaraderie is great, the teamwork is fantastic. What we like to do when we get any kind of free time at all, which on the shuttle missions is not very often, on the space station missions, which are longer duration, you're up there for about 6 months, so the pace can slow down, is look out the window at our beautiful, beautiful planet Earth. And my biggest surprise, I think, and then I'll just show you some beautiful pictures so I can spend some time answering your questions. But I've got to say that my biggest surprise looking out that window for the first time was the blackness of space. And I'd seen hundreds and hundreds of beautiful pictures that our fellow astronauts had taken from the space station and the space shuttle. And I've seen this black a million times, but the true blackness that I saw in space was something that I'd never seen before on this planet Earth. And it's also a black that our cameras just can't capture, and I really wish they could. But it's, I'll try to explain it to you, but like I said, I've never seen it here on Earth, so it's kind of hard to describe. But it's a flat black, so it's not shiny, it's flat, but it doesn't look like flat black paint, okay? You know you're looking through a vacuum. You can see on the dark side of our planet millions of stars, and they're hung on these invisible strings, these pinpoints of light, and you can tell that they just go on for miles and miles and miles and miles and miles. So you know that there's a great depth there, and you're looking through this vacuum, but it seems to have a texture to it. And at first I thought, well, maybe it's like black velvet that's not shiny, but it's not nappy like velvet at all. So the best I could come up with is it's kind of a creamy texture. So if you can imagine a creamy black, but not a creamy black color like coffee, that's what it looks like. At 5 miles a second, you are going around the Earth every 90 minutes, every hour and a half. So that means every 45 minutes you get a sunrise, and then the next 45 minutes you get a sunset. I wish, again, our cameras could take pictures. I think if you look here, do you see about, 5, 6, 7 layers of blues and a couple layers of orange? If you were really in space with me today, you would see more like 20 different layers of blue, and each layer of blue would be a different color. It's amazing to see what we call the Terminator, but where night ends and daytime begins. Check out our atmosphere. that is something that you just can't get away from, is noticing how thin our atmosphere on our planet is, and how we are all of us, every single human being and other animal and plant on this planet are all sharing a very, very thin layer of air. And this is after undocking from the space station. This was my crewmate's favorite picture from orbit. Can you tell this was right after we had undocked? And can you tell why they might have enjoyed this picture the most? Yeah, they loved our shadow of our shuttle on top of the International Space Station. And it's always good to get back home here at this Kennedy Space Center. We had a fantastic landing. I was helping on the flight deck, which was a real honor to get to do. And I can tell you that when Scott Kelly, our commander, landed the space shuttle, we did not feel the two main gear touch down. It was that smooth. You do feel the nose gear when it snaps down. And it was great to be back home, be back here at the Kennedy Space Center. So I think with that, can I